Hello, my dear students. Good day. I hope you are all okay, except the one who is sick. I think Eric is sick today. Um, but it's gonna be fine for him. Me also, I'm very good. I'm okay. So welcome to the class today. Last Friday, we have seen that the changes of state of matter. We also saw that the change of state depends on the two important factors. The first factor, the which was the temperature, which is and we have seen, for example, that changing the temperature can make can make the state of matter to change. For example, here we solid, but when we increase the temperature, you can see we are somehow in a gaseous state. Um, we also seen that the pressure can also have the effect, and the vice versa. Let's have, for example, oxygen molecule here. So they saw the state. For example, if we increase the temperature, what can happen? You can see we are changing from one state to another. Especially here, we are in somewhat is like gaseous state. Mm, yeah. Um. So in this lesson, what we are going to do, we are going to see to study the kinetic theory of matter. That was just an introduction, and we can start asking some questions. Since you are doing physics, I think that if someone says kinetic energy, what does this term kinetic indicate? Hmm? Area, can you please guess? If they say kinetic, what do you understand? Hmm. Can you tell us, please? Yeah, yeah. Kinetic means the motion. Yeah, actually, kinetic is associated with the motion. So, what is kinetic energy? Yeah, it means that the kinetic energy will be due to the energy possessed by substance due to the motion. When substance is moving, it has a kind of energy. That energy we call it the kinetic energy, which means that the higher the moving the particle, the higher the kinetic energy. Yeah. Um. So let's come back to the arrangement of particles in solid state, in liquid state, and see about if they move, where they move it very fast, where they move it slow, where they don't move. Let's see here. So let's start here. This is we have a solid state, we have the liquid state, here we have the gaseous state. Now you can see, as this we have seen it, but it is just a quick reminder. Um, the particles here in a solid, as you can see, are packed tightly together in a fixed arrangement. This means that the particle, they can vibrate, but they cannot move. What do you think about the kinetic energy of those particles? Are they high or low? Cynthia, I think you are seeing the animations. You are seeing the pictures on the projector. Yes. You think that because if I say that the kinetic energy due to the motion, and you have seen the particle which is moving at a high speed has a high kinetic energy. Then we and this in solid you can see the particle they cannot move. They vibrate only in fixed position. What do you think about the kinetic energy possessed by those particles in a solid state? Yeah, actually, you are right. They don't move. They don't move, so the kinetic energy is high or low. Yeah, you are right. It is low. Hence, the particles they don't move. Let's come here in liquid state. The particles are close together with no distinct arrangement. Particles can move and slide around each other. The particles can move. What do you think about the kinetic energy compared to solid state? Isawayo? Yes. They will have a high kinetic. Thank you very much. They will have a high kinetic energy uh, than in solid sense the particle can move, even though the slow movement is slow. This comes to gases. Now let's see. You can see the particles of the gases are they are in they behave like individual. They are independent from each other. So here the particles are free floating with no distinct arrangement. Particles move and collide with each other, but they move very fast. What do you think about the kinetic energy? Did you say? Oh no, I seen. Yes, I seen. Yeah, actually, yeah. Thank you. Because they are moving at a high speed, they will have the high kinetic energy. So that's all. Let's see. Let's come back here and see if they are really moving here. This is just a picture. Let's see how if they move really. So let's start. This is the uh, let's see here. Let's come here. This is the solid state of neo. So you can have even oxygen. You can have it. So whatever you want. So let's use this neon. This is the solid state of neon. But let's see here. Uh, the particles in solid state they are regularly arranged, as you can see, but they cannot move. They vibrate in the fixed position. What do you think about the kinetic energy? Kinetic energy actually is slow. It's not big. It's not. They have a low kinetic energy since they cannot move. They are vibrating in their fixed position. But let's see if we change from solid to liquid. Now you can see the way they are arranged, the way they move. Even though it is they don't move it very far, but they move much more like sorry, they like yeah, much more than in solid, much more than in solid state. So you can see this is the actually we are in the liquid state, and this is what you saw on the previous diagram here, where they were saying that the particles are close together with no distinct arrangement, but they can move and slide around each other. This is what is being seen here in the liquid state. So they will have the high energy than the particles in the liquid state. So let's go on the gaseous state. As you can see, this is uh, what they have been saying. The particles they are very far from each other. They move very fast, and they have obviously they have the highest kinetic energy. So this is what we call the kinetic theory of matter. Or just it's all about the description of the behavior of matter of different particles in terms of the kinetic energy they possess. As you can see, the particles in gaseous state they have the highest kinetic energy than the particles in liquid than the particles in solid. And that's why, for example, you saw that when you increase the temperature for the so from so in so when you from solid state, you can go in the liquid state, you can go in the gaseous state. That is because yes, because they were applying much heat or the high pressure, the temperature, the kinetic energy of those particles, whether in a solid or in the liquid or gas, they will change, and obviously when they change the state of matter will also be changed. And another important thing is that because of this theory, we can engage with some behaviors. For example, if you have a gas, how can we turn it into a liquid or solid state? Eh? What can we do? And we have seen it on Friday. Let's see Friday. See. Let's see here from Isabel. What did you see yesterday? Oh no, last Friday. About the how can you bring the change in state of matter? Mm-hmm. Yes, come on. And try to be loud for you, please. Mm-hmm. Let me mute my microphone so that you can't record. Um. Yes. Hmm. Yeah, you also have to do just to reduce the pressure and control the temperature. Ah, yes, you are right. Because increasing the pressure, it means you are increasing the contact between those particles. Decreasing the temperature, what are you doing? Yes, you are decreasing the motion of those particles. So when the intermolecular forces are high and the movement is slow, it means that the gas can be liquefied. Thank you. Yeah. So according to this theory, let's summarize. According to the kinetic theory of matter, the particles inside the state, they have low kinetic energy compared to liquid state and the gaseous state. And the particles in liquid, they have the highest kinetic energy than the particles in liquid, and the particles in the solid state, they have what? In the gas state, you have the high kinetic energy. As you can see, this is the solid state, this is the liquid state, this is the gas state. So that's all about the kinetic energy of molecule of matter. And you can see there is another important property related to this, which is diffusion. Mhm. In this, the diffusion is so related to the kinetic theory of matter. What is diffusion? What is it? So let's see. Come here and see what is really the diffusion. And it is a very, very important concept in chemistry. So maybe we will come to know the definition at the end of the video. Also the simulation. Let's see. Here I have the particles. Let me see. I needed to add you can click here and you add the red ones, and click here to add the so I have 10, they are equal. You're going to see because I can even start with only one kind of particle. Let's start with only the red one. So using what I'm doing here, you can see here I have 70 red one particles. And here I can see the mass I can even reduce their mass. Yes, the mass. Let me make them The mass, when you can see, what do you think about? You can see the way they are moving when the mass is low. They're moving very, very fast. Yes. Let me see if I decrease also the radius. Can you see what happens? The way they are moving. Yes. I can even increase the temperature. Initially I was at 300 Kelvin, but you can see the way they are moving. They are moving very fast, and those different parameters can be controlled to see how they affect the rate of diffusion. Uh, so I can even add the green ones. You can see they are very big. The way they move very slow. Their mass. Let me try to reduce their mass. But if I reduce their mass to see if really their movement can be increased. I mean, yes, yes, we can see the movement is they are moving very high. Let's see the radius. If I make them small and I increase also the temperature, the way they are moving. So I can also let me mix them together. If I remove the divider, let me see what is going to happen. You can see they are now mixed. Some particles are moving from left to the right, other particles are moving from right to the left. And this movement of particles from one area to another without energy is what we call diffusion. So let's come back and see. Let's start with only red ones. So this is the array 19, the mass is 28, the radius is 125, the initial temperature is 300 centigrade. Now let's see if we remove the divider, what is going to happen. You can see here I have they are concentrated on this region. Then here we have a zero, or there is no particle here. Let's remove the divider and see what will happen. So you can see this arrow is indicating the net movement of particles. They are moving from right to the left, where they are highly concentrated to where they are at low concentration. This movement is what we call diffusion. So I can start again, but let me increase the temperature and see. Those are different factors. The factor that can feel the rate of diffusion are the temperature, the concentration, the particle size, and the mass. This one we have already seen it, because when let's explore the effect of temperature, for example, the particles I have 10. I only change the temperature and I make other factors constant. You can see. Let me remove the divider and see if they are moving very fast. So you can compare their movement at 500 centigrade to the for example 300. So you can see they are moving very slowly, very slow. And so you can see when the temperature increases, the rate of diffusion also increases. That's the first factor. And the second factor can be the mass. Let's see here the mass. Let's make them 4, and let's add the 150 particles and remove the divider. This is what will happen to the rate of diffusion, since you know. So you can see the way that they are moving very fast. Yes, which means when the mass is low, the rate of diffusion is high. I think it's obvious. Are you seeing this projector? Yeah, good. And let's come on to Let's reset it. Let's also have seen the mass. Let's see the effect of radius. I can see they are very big. Let me try to reduce their radius, make them very small. And can we reduce their masses? If they are very small, so let's increase also the temperature at the same time. You can see. Let's see the rate of diffusion. Now you see the way they're moving very fast, which means the rate of diffusion is very high. I can even let's see. No, let's mix two different particles, and no, let's give them different radius. Their number, let's make them equal here. Let's have 10. No, let's give them the 20, so that we see where they are moving if at a high region, the high speed. The temperature, they have the same temperature. And let's see, as you can see for this one, I have the small number. Their mass is small, and they make their mass the same. This is the radius. Let me make their radius similar, 55, which means you are able to see if the concentration really affect the rate of diffusion. And we remove the divider. Let's see what is going to happen. So what does those arrow indicate? You can see from right to the left, the arrow is somehow longer than this one, which means much of the particles are moving from right to the left, and less particles are moving from left to the right. That is true, because here we're having too much particles than on the left here. That's why. But after some times, we reach the equilibrium state where we find that the rate of the particles that are moving from left to the right will somehow be equal after some time. And this is what we call the diffusion. In our everyday life, the diffusion is a very important in our everyday life. For example, when we are breathing, taking the air in the lung, the process by which the lung the oxygen or other gases enter in the lung is called diffusion. Even when it is entering especially the lung tissues, especially the alveoli, these gases enter there by diffusion. From outside where we have too much to the inside where we have low oxygen or low gases concentration. Even when we are sometimes if you accidentally broke the rotten egg in this room, what can happen? For example, what's going to happen there is that after it is broken at here at this where I am, after some time you will notice the very bad smell, even at a given distance. What's that? It means the gas, especially the hydrogen sulfide in the rotten egg, is spreading from one area to the another area by diffusion process. Let's see the plant, the oxygen or how carbon inside the leaf. I think you are doing also biology. You know that there the oxygen or carbon dioxide, they are diffusing from the environment to the leaf, or from the leaf to the environment. And in chemistry, you can see one practical example where we can see what happened. For example, if we add the food coloring or coloring substance in water, let's see here the practical example on the diffusion. in this video. The video is going to show us potassium permanganate in water. Let's see what is going to happen. So as you can see, this is water, and so let's see from here. Now you can see this is the potassium permanganate here. The potassium permanganate. This is solids. There was a purple, so the gray solids. Sorry. Let's see if they are dissolved in water. What's going to happen?
Brightly colored once added to water. Let's observe what will happen now. Look keenly. When added to the water, the potassium permanganate crystals, they dissolve. Where most of them fell in the bottom of the beaker, and that is referred to as an area of high concentration, to the top of the beaker, and
That's what is saying. I think maybe it is a problem with the microphone, but you can see when it is added in water. At the bottom you can see this is where we have high concentration of potassium permanganate particles. But you see they are spreading here at the top where we have the low concentration.
areas that you cannot see of low concentration. So we'll take a break, right? And of
Let's see
course,
what you can see they are spreading all over the water. So this is what we call the diffusion. Thank you. If you have a question, you can ask so that we can have the common understanding. That's what's about the kinetic theory of matter and the property which can be described by the properties by the kinetic in theory of matter, which is the diffusion. That we have seen the diffusion. But in every day we receive, for example, that the food coloring substance, for example, if you add, for example, the tea masala, the whatever in the food, when they are hot, they spread it too much than in cold water. That's because in hot water or the hot food, the molecules are moving very fast so that they spread very easily. So thank you for your attention and your presence. This was about the kinetic energy of theory of matter. You have seen that the particles inside they have the kinetic energy. For example, this is the solid. Then you can see the raw kinetic energy, but they don't move. They vibrate in fixed position. And you can have here in the solid liquid state where the particles they can move past each other. They have high energy, kinetic energy, than the particles in the solid state. And you have seen that the gases state has more kinetic energy than the solid state and the liquid state. We have seen also the diffusion, which is the movement of particles from one area to another, especially when they are high concentration to where they are at low concentration. And I've seen the practical examples where the potassium permanganate was dissolved in water and it is spreading from where it is from high concentration to where it is high concentration. And we have seen the everyday application of diffusion. Thank you for your kind attention. Let's see another day. Have a good day.